So today we're going to do lesson 20, which continues our work with converting measurements to different measurements. And the thing about lesson 20 is that it mixes up going from small units to big units and big units to small units, which means we need to be really careful with double checking if we're going to multiply or divide for every single problem. So you have to make sure to check these steps and don't just assume that it's going to be the same pattern, because it's not. Remembering that when you're going from a big unit to a small unit, you multiply, and you go from a small to a big, you divide. So keep that in mind as we go through and work through some of these problems. Let's start with C. C is 3 5/6 feet equals how many inches? Well, the conversion is still the same. We're going from feet to inches, which is a big unit to a small unit. So I know I'm going to multiply these, and my conversion factor, which is 12 inches, is in 1 foot. I'm prepared for my conversion, but what's putting me on pause is the fact that 3 5/6 is a mixed number. Yesterday, we looked at converting numbers that were only whole numbers. Today, we have mixed numbers. And to multiply or divide a mixed number, we have to do a little pre-work first. We need to take this 3 5/6 and rewrite it as a mixed or as an improper fraction. And the way we do that is we think about this 3. I know from my previous knowledge that 1 can be written in any kind of fraction as long as my numerator and my denominator are the same. So 1 can be 1, 1, it can be 2, 2, or it can be 6, 6. If I have 3 1s, that means I have 3 6 6s. So I have 6 times 3 over 6, which means I have 18 sixths. So the 3 can be thought of as 18 sixths. Well, 18 6 plus 5 6 gives me 23 6. So 3 5/6 can be written as 23 sixths. You might have seen the shortcut of doing 3 5/6 of timesing the denominator by the whole number and then adding our numerator. So 6 times 3 is 18 plus 5 is 23. And we do 23 over 6, which is the exact same as what we have over here. So you can think of it in the shortcut way, or you can think of it in longhand way, as long as we know how to go from a mixed number to an improper fraction. So now I can do my conversion. I have 23 6, and I'm going to times it by 12. Well, flashback to lessons ago where we multiply a fraction by a whole number. 23 6 times 12 is the same thing as saying 23 times 12 over 6. You can simplify, you can multiply straight across. I can see that 6 and 12 can be both divisible by 6, so I can divide 6 by 6 to get 1 and 12 by 6 to get 2. So I end up with 23 times 2 over 1, which, if I do off to the side, 23 times 2 is going to give me 46 over 1, or 46 inches. So this one is converting. Yes, we're still finding our conversion factor. We're still deciding if it's going from a big unit to a small unit. And so we're going to decide if we're going to multiply or divide. But the added extra on here is going from a mixed number to an improper fraction. So let's practice that again with E. 4 3/10 of an hour equals a certain amount of minutes. So 4 3/10 of an hour can be rewritten as 10 times 4 plus 3, which gives me 43 tenths. So 4 3/10 of an hour equals 43 tenths. Well, when I go from hours to minutes, I'm going from a big unit to a small unit, so I'm again going to multiply. And I'm going to multiply by 60 because there are 60 minutes in each hour. So 43 times 60 over 10 gives me the equation of 43 times 6 over 1, which you can multiply and you'll get your final answer. So again, we're going from a mixed number to an improper fraction and then going through our conversion steps. Now, it just so happened that these two examples are both going from a big unit to a small unit, but you'll note they're not always the case. For example, 33 months is how many years? Months is a smaller unit, and years is my bigger unit. So I'm going to end up dividing here. Pints to quarts, pints is smaller than quarts. So I'm going to end up dividing here. So you have to make sure you're double checking what operation you're going to do. I do want to show you D because it's a little different, and we're going to have to do some thinking with this one. So 7 1/2 pints is how many quarts? I know I'm going to divide, and my conversion factor is 2 pints equals 1 quart. So according to my pattern, I would turn 7 1/2 into an improper fraction, which can be 15 halves. And then my equation would be divided by 2. Now this is where I want you to stop, and I want you to look and say 15 halves divided by 2. Think back in your time and say, has Miss Saunders ever had me divide with fractions? No, I've never once asked you to divide with fractions. So I'm not expecting you to divide here because you don't know how to do that yet. What we have to think back on our time, though, is we have learned that dividing by 2 is the exact same thing as multiplying by its reciprocal, by multiplying by 1/2. For example, if you're doing 6, 6 divided by 2 equals 3. 6 times 1/2 equals 6 halves, or 3. So you can divide by a number, or you can multiply by its reciprocal fraction. So in this situation, because it's our fraction that we're trying to convert, I can't actually divide by 2. I'm going to rewrite this as 15 halves times 1/2. And we talked about this when we looked at converting and how you can divide by or multiply by a fraction, so it shouldn't be a completely unfamiliar concept for you. But just know that if it comes into the play where you have to divide a fraction, you can always, instead of dividing, multiply it by its reciprocal. So now I have 15 halves times 1/2. 15 times 1 is 15. 2 times 2 is 4. So I get 15 fourths, or 3 3/4. So it's 3 3/4 quarts. Let's apply in a word problem. We're going to do number 3. Horace buys 2 3/4 pounds of blueberries for a pie. He needs 48 ounces of blueberries for the pie. How many more pounds of blueberries does he need to buy? So he has an amount in pounds. We know the total needs to be 48 ounces. And we want to know how many more pounds he needs. So if this was my tape diagram for this problem, I know he needs 48. So 48 ounces is going to be my top. We're looking for how much he has to buy. And we know he's already bought 2 3/4 pounds. Looking at this tape diagram, this is a subtraction tape diagram. So if they were all the same units, I could subtract and find my missing piece. But they're not all the same units. I cannot take away 2 3/4 pounds from 48 ounces. I need to convert them to be the same unit. I'm going to go ahead and convert my 48 ounces into pounds only because my question is asking about how many pounds. So I might as well do my converting to pounds now. So I want to know 48 ounces equals how many pounds? Well, I know there are 16 ounces in 1 pound. I know ounces are smaller than pounds, so I'm going to be dividing. So I'm going to do 48 divided by 16 will give me my answer in pounds. I happen to know that 16 goes evenly into 48 and it goes in 3 times. So that means in total they need 3 pounds. So basically we can rewrite this tape diagram and put 3 pounds on the top. So I have 3 pounds. He already has 2 3/4 pounds, and we're looking for that mystery amount. Well, we already talked about a subtraction tape diagram. So 3 minus 2 3/4 is going to give me 1/4. So Horace needs to buy 1/4 a pound of blueberries. So main takeaways here are converting with mixed numbers. You treat them the same way. You have to figure out what operation you're going to do. You have to find your conversion factor, but you need to make sure you turn your mixed number into an improper fraction before you go through the converting steps. And the other thing we have to keep in mind is if you're converting a fraction and you're going from a small unit to a bigger unit, and they ask you to divide, that instead of dividing, you can multiply by a fraction, because those are the exact same thing. Divided by 2 times by 1/2 will give you the same answer. So you sometimes have to be flexible and not follow a root pattern. You need to address each problem on its own individual level.